This is going to be the final event of the evening. Afterwards, you'll have some time to mingle and chat. This is a panel. I'm joined by Matej, Ismael, and Tracy. If you wanted to first run through and give a short introduction of who you are and what you work on at the moment. Starting with you, Matej.
Yeah, so I'm Matej. I was an academic mathematician for a very long time, for a few years. And then I got into ZK in 2022, and I was an engineer working at Livengood for a while, working on the Lurk programming language, where I kind of got to learn about how ZK works. And now I'm working on formal verification of ZK stuff at Reilabs.
My name is Ismael. I'm one of the founders of Lagrange. I gave a talk a few minutes ago, so I think you all have heard enough from me.
Hi, I'm Tracy. I'm founder of Pluto. I didn't really introduce myself in the talk, actually, but we're working on web proofs and the sovereign internet that I talked to you guys about. My background's in software engineering. I was a software engineer for like 10 years, and now I'm a founder.
Thank you all so much. So I encourage any questions from the audience if you've had any come up throughout the evening. I also have some here to get us started, if not. I mean, I'm personally curious about some of the stuff that Luke was putting up, and I guess also what Reilabs is doing now, as only I've recently learned about some of their work.
Yeah, well, so back to Lurk, I mean, there was a Lurk programming language, which was kind of like the main engineering effort was being put into that. But I think it's hard to sell a programming language. So like, you know, the economic interest was coming from this other project that we were starting to work on, which was Proofcoin, which was this idea of bringing Lurk proofs on chain and sort of like a blockchain that can verify many different kinds of protocols and that kind of stuff. And that was kind of like the state of things when I left. At Reilabs, we're doing everything. We're working with tons of people in the ZK space, WorldCoin, Aztec, like big names, much smaller names as well, and the kinds of projects we're working on range from like working on compilers, working on really low level like hardware acceleration for cryptographic algorithms, and stuff that I'm working on in particular, which is formal verification for various crypto applications.
Right. Very nice. I remember when I first met you, we were talking about something in Lean that was formal verification.
Yeah.
Back to doing what you love. This is excellent.
Yeah. So I took a little bit of a break from Lean when I was working on some more of the Lurk stuff, and now I'm like really excited to get to do Lean stuff again.
Well, I could have a question in a very different direction, which is a very recent thing that came out was Fiat-Shamir security issues that people have found with it, which I think maybe all of us have seen the recent tweet, and I myself haven't read the papers, so I'm not feeling super great about diving into all of that. But a more general question is, how do we feel about some of the security assumptions of ZK for these things like Fiat-Shamir? It feels like there's a couple other hand-wavy examples. And are we building things that are now going into production that still rely on some maybe incorrect assumptions of security?
So I believe the Fiat-Shamir tweet was about an exploit in like the GKR transcript construction, something like this. As far as I know, this doesn't impact like most of the Starks that do not touch GKR, Starks or Snarks. But yeah, I think it's sort of, to me, there's like as the technology grows in adoption, the depth that any particular person goes to ensure its security increases. So I think these things kind of like march forward in lockstep. So I would say on like a technology security point of view, I'm not a doomer. I'm like, you know, as things get bigger adoption,
Let's break.
We will break them better, but we'll also like formally understand them in more detail, and alongside it as sort of the market demand for this grows, we'll invest more in the security so that in tandem they can ultimately secure more value. So it's nerve-wracking a little bit when these things happen. If I had like a GKR snark in production securing a bridge or something, then I'd be like losing my mind a little bit right now, but I'm not personally in that situation, so.
Yeah, I mean, to that point, the vulnerability doesn't affect the modern proofs that people use, since GKR is not used in production by really any team that I'm aware of. And plus, I think there are ways that were suggested in the paper to rectify the problem that was presented. And so, our team uses GKR for some of the ZKML stuff. It's probably the most performant prover for ZKML, but there's ways that you can structure the prover such that you don't face that vulnerability.
I mean, I guess my understanding of the problem was that, well, so GKR is proven secure theoretically in the random oracle model, but then the point of the paper was that for any particular instantiation of the random oracle in terms of a hash function, there exists a broken GKR circuit. So that GKR circuit that breaks the security assumptions is tailored based off of the hash function that you use. So there is a way around it by like just don't choose that circuit. But that also kind of gets into, not to show formal verification, but that gets into the kind of interesting thing about formal verification where you can like verify a protocol at different levels. And so you may have like a paper proof or a formal verification for the protocol layer of some sort of implementation, but then you really have to get into like the circuit level verification to make sure that the circuits you're writing are secure. But then you also need to have kind of like an implementation level verification as well. So I think there's like a lot of formal verification that needs to get done, and like as more money is flowing through these things and as they become more security critical, you're going to see a lot more effort in terms of like verifying the correctness on all three different layers. So just, yeah, it's just a matter of time.
Yeah, building a little bit on that, since we've seen a lot of more mind share go into crypto as of late, how do you feel like that's going to affect like the velocity of what we're doing and how we approach working in ZK? Just that cryptocurrency.
Yeah, so I think one of the things people overlook about crypto and ZK is that ZK is the only area in crypto where you could confidently say that the world expertise in this field is concentrated in crypto. Right? Nobody would argue that crypto X AI, the AI researchers there are nowhere near as talented as the AI researchers just focusing on AI in general. No one would argue that like distributed compute or high performance compute in crypto is anywhere near what you'd see in like HFT or like streaming for like Web 2 services like Netflix, right? We in many areas of crypto have a substantially reduced talent base compared to the broader market. But ZK is the only area where like the actual research and engineering quality that we see in industry surpasses what we see anywhere else. There's no Web 2 comp for like ZK engineering that's anywhere near as competent as what we see in Web 3. Academic work in ZK is fascinating and pushes the state of the art, but the quality of engineering work there is nowhere near what we get out of ZK in crypto. And so one of the best things produced in crypto has been hundreds of millions of dollars of financing pushed into ZK systems that are reaching production. And the applications of those are going to be in crypto principally, but they're also going to be used outside of crypto. And we're going to continue to see an acceleration to that end.
How do you think about those systems that are coming outside of crypto in ZK? How much of those are making use of blockchain, and how much of them are full in Web 2?
Yeah, so, I mean, like, the application of crypto, of like blockchains outside of crypto, I think is somewhat dubious. Like private enterprise blockchains, I think, are a little dubious. Where I think it's actually
at the moment, like projects that are primarily in Web 2, but maybe for currency or for fees, they use
ZK.
They use crypto.
Like photography.
Yeah. No, like cryptocurrency. Sorry.
Oh, so you mean like people in Web 2 who use crypto?
Like I've seen ZK TLS projects, which primarily exist for Web 2 use cases.
But they bring aspects on chain.
But you might use USDC, for example, as like this is a value add for an automated transaction.
Yeah, I think that's great. I mean, I think the use of crypto for payments in Web 2 apps is
It's
very
like
clear.
stronger than what it is in Web 2.
It is.
Plugins.
Yeah.
I also think there's like a convenience aspect as well. I was at ZK Summit 12, and there was just like tons of people coming from all around the world. And it's like, oh, do you use Venmo? No, they don't have Venmo in my country. Oh, do you use PayPal? No.
International events.
Yeah,
you have the use case right there.
Yeah, and then it just was like, oh yeah, okay, we all have this thing. And just use it. And it was really neat. So I think like even for like non-internet things, but just like human-human interaction has been helpful.
So when I went to DevCon in Bogota, I had a late flight from San Francisco. It's like 11 p.m. I took a nap, woke up, grabbed my bag, ran out to the airport, got on the flight, slept on the flight, got to Bogota, and then I got to my hotel and I realized I forgot my wallet back in San Francisco. And so I'm in Bogota with no credit card or debit card. And so I called back to like, I have my phone and I have like my crypto wallet, but I can't get cash out. And so I called back to the US and I call my co-founder and I'm like, can you send me some money? And so I had to go through the whole process of trying to figure out how to get money from the US to Colombia. And we ended up sending it through Western Union. And we had to wait for the Western Union transaction to clear, which took a bunch of hours. Then I had to withdraw a large amount of cash from Western Union in like small denomination bills and like pack it into a backpack in somewhere where I probably shouldn't have been in Bogota because the Western Union station was not a nice area. And then I had to take that back to my hotel so I could spend the rest of my trip paying in cash. So it would be much easier if the world just took USDC.
I'm curious to talk about MPC and ZK and where it shows up in a number of places. I've heard ZK-TLS called ZK MPC. I know there's co-stacks that Lucas talked about last time, as well as some proof markets being unlocked with MPC. Do we feel like it's ready, or like, what are your thoughts on how usable and incentive-based some of this stuff is at the moment?
Yeah, I think it's ready. I mean, like CoSnark's work, I think the Tasio team built an implementation of CoSnarks, which I think is, the performance is like equivalent to running a client-side proof, so it's surprisingly performant. Like you would think if a client-side proof is 1000x slower than standard computation and MPC is 1000x slower and you combine them together, you get 1,000,000x.
End up in a horrible situation.
Right, but there's actually a paper that shows it's about 1000x. It's surprisingly efficient, and they leverage this fact to make CoSnarks. I think the concepts that power CoSnarks are kind of poorly understood, and I think application developers haven't fully grokked the capability of the technology. And so I think that's going to start coming more over the next year or two, but it's kind of a gradual come up, I feel. The coolest product I've seen on that is Renegade, which uses CoSnarks to do private like dark pools, so that you can exchange assets and then use a snark to prove that you did the exchange privately correctly. But I think there's more permutations of that are really cool. And then obviously web proofs, I think, I don't know that I'd call it like ZK MPC. I think it gets like confusing to kind of munge all these things together like this. But basically, I do think multi-party computation is super powerful, and we'll have a lot more uses over the next few years. I think we're not nearly as far as we should be with it.
What do you think the adoption will look like in the next year?
Adoption of MPC. I think web proofs is probably the most like exciting adoption vector right now. I think the primary use cases of like web proofs that'll be explored, I think, are the simple ones right now. So that's like referrals is one I've been talking a lot about. That's like I run on Strava, and so I get a discount when I buy my Whoop, you know, and I like prove that I ran on Strava to like get this referral code that gives me a discounted Whoop. Kind of like building these little bridges between products and services online, and then credentials. So like being able to show you're a resident of a county or a resident of a state or have a certain income and getting access to either like a social group or being able to participate in a group that you otherwise couldn't without that credential. So these are the simplest uses of like web proofs and data interoperability, and I'm pretty excited about them.
I think I have a slightly different view. So I think MPC is already broadly used in crypto. The entirety of Definity runs MPC, threshold signature schemes. So the application of MPC for proving, I think, is a bit early from a usability standpoint. I don't see enough demand for client-side proving currently to justify building networks to make it easier to outsource client-side proving to those networks. We generally haven't even seen privacy tech in crypto find very wide adoption. Like you can do private transactions on secret network. People don't really want to do that. You can do private transactions on what's the other one? Zcash. They've never really gained adoption. Aztec and Alio, both are privacy preserving, and people generally haven't really built or been interested in building those areas. And so, as much as I'm excited about directionally privacy is very important, I don't think specifically with how users are expressing price preferences over the types of applications and chains they interact with, there's enough demand to justify building networks to support easier privacy preserving proving. I think we should establish the market, we should see the market established first for privacy preserving proving client side, and then see the pain point develop where users are like, hey, I want to outsource this to a network, and then we build networks. Instead of building networks as a bet on top of the private blockchain bet on top of the consumers want to pay for privacy bet. It feels a little solution isn't here right now.
Well, it feels hard for individual consumers to say, I want privacy and get that, versus finding use cases that demand that, and then seeing if that justifies an infrastructure that has it.
Yeah, I think very simply, I want to see there be enough proofs being generated client side to justify the need to outsource those to network. But directionally, I think it's exciting.
I also think it's important not to conflate client-side proving and privacy. There's private blockchains, that's
Yes.
one thing, but I think you said it's against my take or something, but that's not even my stance. So I could position a different stance, but I just generally would say I think MPC is powerful for things that are not just privacy and not private blockchain transactions. Historically, it's been used in a very narrow way for threshold signatures. It's not generally programmable MPC. And I think some of what we're seeing now is more generally programmable. MPC VMs, for example, which allows multiple parties to collaborate on a computation. And in that environment, often privacy is actually very impactful for economic efficiency. It's not about user and consumer preference for privacy, it's that you get better economic efficiency if you can exchange privately. And so if you look at traditional financial markets, a massive amount of it happens in dark pools. And that's because it's more efficient for them to exchange in dark pools versus to put it in a public order book where they'll get front running. Yeah. And so similar dynamics exist in blockchains, where if you go put your transaction in a mempool, right, you're going to run into potentially front running issues. Whereas if you can do things like house swap or private exchange, you don't have those same issues.
I agree with that, yeah. I think Renegade's a very interesting project. I thought there was in TEs.
Nope.
Okay. Very cool.
To clarify on what you're saying about conflating these two things, the notary example that you gave isn't really about privacy, it's about this is just the only way that you know the direction.
Yeah, there is an important privacy aspect of it, which is, if you use Facebook, your authentication token to Facebook is like your private key for Facebook. It's very, as a user, it's very important to you. You don't just put that on Twitter, right? So that other people can use your Facebook private key. And as a user, to build a product that uses that Facebook private key, it's very important that you build it in such a way that that information doesn't leak or get exploited in some way. But it's not about privacy in and of itself. It's just about security and reliability for the user.
Curious if any of the audience has questions or directions that you're more curious about. Matej, it feels like you more work on the technical, the formal things, and less of this product high level.
Yeah, very fun.
Curious what you're excited about in ZK at the moment.
I guess there's back to formal verification, but there's this big formal EVM project where the Ethereum Foundation is throwing a lot of money people working on a lot of different directions in that area. And it's a very large pie, you know, with a lot of money in it for a lot of people to, you know, get a slice of the pie. So, yeah, I mean, that's a really exciting area. And then also just research-wise, I'm a little bit, I think research-wise, I'm pretty excited about client-side proving. And in particular, a lot of the folding schemes that are starting to show up, like MiniNova, a new paper that just came out like a few weeks ago, I think, has a really impressive performance footprint compared to previous implementations of Nova. And I think, like, you know, there's just like at a high level, there's this like snark versus stark kind of competition going on, and the eternal battle, yeah, between like hash-based proving systems and elliptic curve-based proving systems. And I think maybe 2024 was like the year where hash-based provers really got into a stride, and like a lot of implementations were being built on top of hash-based provers. But I think for client-side proving, folding and Nova-style proving systems is kind of a pretty exciting way of thinking about things, and I'm excited to see like what comes out. And I you know, like when researchers spend 15, 20 years of their lives on elliptic curves, it's not an easy switch to go over to thinking about hash-based snarks. So they'll do everything in their power not to think about hash functions. And so, you know, there's that motivation there that I think is going to like create some really interesting research.
It's this meta-level incentive structure.
Yeah.
My thing is right, I don't want to have to relearn everything.
Yeah.
Have you looked at latticefold?
Yeah, latticefold is really cool. I mean, I have a kind of a casual interest in post-quantum cryptography, and I think if it was up to me, I think a lot of the like super singular Diffie-Hellman style with isogenies is maybe more interesting, just because I'm a sucker for elliptic curves. But I think lattices are really interesting, and latticefold is kind of like, yeah, the first step in the direction of trying to implement, yeah, folding schemes on post-quantum secure kind of implementations.
That's interesting. I'm not as deep in the math as you are. I dabble, but I think when I implemented pairing, I was very excited when I implemented a tape pairing and like actually got it to work.
Yeah,
and then it checked out and the multiplication worked. I was like, this is magic. I can like go into this R torsion magic land and then check the pairing, and it just like works.
Yeah.
I remember feeling like, oh, this is like beautiful math and it's really special.
Well, I think it's really cool because it's like really, yeah, really beautiful math and these incredibly abstract ideas. And as an academic mathematician, I was like playing with these things in such an abstract way on pen and paper that I didn't even have the concept that I could actually calculate these things. And it's through like necessity that engineers have really sat down and like Miller, you know, with the original Miller loop was like, no, we really want to calculate pairings because this is going to unlock some interesting
Computation time is important.
Yeah, and it's going to be important to calculate this. So like, how do I do it? And that's just like, yeah, and you know, so much of pairing-based cryptography has just come out, not even from the math, but from just like wild optimizations that have come up over the years.
Do you want to broach the topic of like ZK AI? Do people have any thoughts about this being?
I have very strong thoughts. I mean, I think verifiable AI is probably the future of all AI. The idea that we're going to use inference for societally relevant or defense relevant functions without those things being verifiable is a scary concept long term. Specifically of the models that are being run closed source, or you don't want to disclose the weights. I also think training over private data is very important. I think going to be a combination of ZK, either MPC or FHA. And yeah, I mean, I think we're going to see almost every model have proofs associated with it directionally in 10 years, 20 years. And so right now it's way too inefficient to be usable. The overhead in a lot of ZKML papers is like 100x plus, but, you know,
Even for just inference time.
yeah, even for
It's
just time,
inference.
yeah. Like, I think ZKCNN is like 100x at least. But,
I don't think we do much better than that. No.
pardon?
I don't think we do much better than that at the moment. No.
Yeah, but, you know, I do think directionally it's different, right? We've seen, like, the overhead on using ZKVM was incredibly high 2 years ago, the first version of ZKVM. And now it's, you know, it's close enough to the performance of handwriting a circuit EVM that every single ZK rollup team is going to just use ZKVMs.
Yeah, we should verify all important computation. Yeah, so that seems reasonable.
Yeah, I was really skeptical of ZKAI. It just kind of sounded like a thing where it would be really easy to sell to VCs.
Yeah.
It has the two like buzzwords that everyone likes to hear. But, and I mentioned this to one of my friends who's a grad student at Northeastern, and I was like, no way, this stuff is real. No, it's real. Like, and here's like some libraries where you can actually, like Ezekiel in particular, is like a very easy to use library.
Also in Boston.
Yeah, and that's how he knows about it. But I was like, yeah, this is actually usable, and I played around with it, and I was pretty impressed. And I think I got to recognize that there is that overhead of ZK on top of, like the overhead of just doing a computation in ZK versus doing a computation without proofs that exists. But AI is just literally matrix multiplication, and we have like good protocols, GKR, to do matrix multiplication. We just have to be a little bit more clever, and I'm really confident that I think it's gonna get to the point where it'll be legitimately usable, like that 100x overhead is gonna turn into something much smaller.
Do you feel like there's an underrepresentation of projects working on this right now? Because as compared to things like proof markets or ZKVM still.
Yeah, so I would say, no, there's not a representation.
It's just early or what?
One of them was acquired, or was merged, modules, right? They joined WorldPoint. EZKL exists, Polyhedra exists, that's pivoted into ZKML. And so there's not a market right now probably for ZKML. Like if you had a 100x overhead model, it's not going to generate you enough revenue to justify the OpEx you're going to put into building it. And the thing with ZKVMs is that there is a market, right? And the market is L2 proven. And that's why there's so many teams building ZKVMs. When there's enough agents being used on-chain production that use your demanding verifiability over the models, then we're going to see other companies start building ZKML that has a market they're selling into that exists. Right now, it's a bit too early still. We have multiple projects already doing it.
So you think it needs to be models being on-chain that then want to be verified, and not what being on-chain represents for models is that you have verified entities?
Yeah, if you can't sell the product using an OP or economic design, like low security preference protocols, you can't expect that making it verifiable is going to make it any more compelling. Because there's a certain section of projects that exist that don't care about security. And if none of them are willing to buy the thing outright right now, then the market needs to be developed before verifiability needs to be developed. That's my opinion.
I think we're also early in the arc of AI progress as well. So like we, at least as far as I'm aware of, there's not like a business that's doing automated invoicing using like an AI model, and like that's like a multi-billion-dollar business or something. I mean, it's just a very nascent market. And I think as AI like kind of fills the crevices of doing more financially valuable and important collaboration between businesses, then it starts to cross the chasm of being used in finance, and maybe starts being used in crypto, and once it starts getting more used in crypto, more verifiability becomes more important. So I think there's just a progression of these things that takes time to play out.
I mean, keep in mind, the only reason that ZKVM is having a market right now is rollups. That's like the killer application right now for ZKVM.
Solana better not win.
No, I mean, that's the killer application. I mean, like, if you were to say, you know, what's the TAM on proving right now, and what percentage of that TAM is it's rollups. It's 95% plus rollups. So, is there a TAM for proving of agents? Possibly. But let's see the agents develop. Let's see there be meaningful financial exchange based on AI, and then let's verify it.
topics on people's minds that they want to shout out?
Yeah, I got one. So there was a whole cycle of funding for ZK companies building ZK infrastructure over the last, the last 2.5 years, starting predated 2.5 years ago, going up to about maybe 6 months ago. We saw this explosion of funding over a 2-year period. We're going to see 5 to 10 of those companies launch tokens this year, realistically, right? From ZKVMs to proving infrastructure to ZK TLS projects, we'll see a bunch of them launch tokens. And so we're going to see how the first crop of ZK-centric projects perform, and that's going to have substantial impact on the funding environment for ZK companies. Let's say 2 or 3 of those, exactly. 2 or 3 of those is really well, all of a sudden ZK is an investable category. 2 or 3 of them, they all do very badly, it's going to become very hard to keep financing in private markets, is what my thesis is.
That's damn good take. That's Tracy. I've been less into raising and paying attention to that one.
Yeah, what do I think about that? ZK companies launch tokens, token goes up, drives funding. That seems fine. Yeah, that seems reasonable. I think that I think you can segment an investor appetite into this technology by those that care about the token outcome. And so those that care about the token outcome is probably 90% of crypto investors. And their vision for your business is that you're going to emit a token that they can sell. So they're like, hey, in some time horizon, this business emits a token, I get my money back and I can raise more money. And that's probably 90% of crypto investors. And so for that 90%, what will matter is this signal, whether they go up or they go down when they launch. Yeah.
The investors have a fiduciary obligation that they should care about that thing.
That's right. Yeah.
They need to return capital.
That is how investing works.
Yeah.
Exactly.
So I hope that 90% becomes 100% because legally it should be.
No. There's different ways to return capital and different time horizons.
Right, but over the life cycle of a fund, you need to return capital, which is 10 years.
Thank you for clarifying. So 90% of the investors care about a shorter time horizon, and that shorter time horizon involves a token on a pretty short one. But there's about 10% of investors who care about a little bit longer time horizon, and they think about building longer term businesses. And for that cohort of investors, they care less about that short-term token outcome, and they care more about the fundamentals of the technology, the importance of it to an evolving internet, and they're willing to be patient and invest in that technology as it grows and evolves. Now, they're not willing to put $100 million behind it if there's no PMF and no business, but they will put small amounts of capital into that in perpetuity, pretty much, because they're convinced of this direction. So.
I see that for very early stage investors.
Yeah.
But if we want to see the category continue to be able to finance production grade engineering, it needs to have businesses that perform well commercially and are able to return capital in size, right? That's how you're able to have ZKML, ZKAI, ZKTLS, ZKVM raising hundreds of millions of dollars financing systems that are going to be used rigorously.
Right, you need product market fit for hundreds of millions of dollars.
And there's not revenue or product outside of tokens.
Well, there's not a large enough demand outside of tokens, right? But what the good thing about tokens are is tokens trade at a very high multiple on fees. That's a really, really good thing about tokens. And it means you can have what we've had, and a lot of people in crypto go, I hate tokens, I'm in different tech, but we've seen investors put hundreds of millions of dollars into fundamental ZK companies because of the economic outcomes that were associated with doing so, right? Across Starkware, ZK Sync, Alio, Aztec, Risk Zero, Sync, we go down the whole list. It's probably close to $1 billion invested over 2 years in fundamental research and engineering on verifiable compute. That's a great thing, and I want to see that continue to happen. That means that some of these companies have to return money.
And this is the way to do it.
And we're going to see this year if they do. So maybe we see another $2 billion put into this next.
I'm more naive towards the VC, the raising, all this stuff, but my understanding, and you can say this is wrong, is that was slightly less the thing of today. It was more the thing of a year ago in terms of token exits.
Yeah, I'm not a liquid market expert, or a venture investor, but
this is only what I've heard, so I don't actually know what the new playbook is. feels like that was changing.
I guess we'll see. We'll see this year what happens.
My hot take is that it's not going to start off as a hot take, but research and development is expensive, and it's really important, and it's what got us to the point where we are right now. And if you look at previous situations where R&D existed and was funded well and brought about many of the innovations we have today, a lot of it was related to patents. And so, and this is like almost anti-everything existing in blockchain, but like maybe closed source patenting technology might need to become more common if we want to start developing technology that can sustain itself without having to do these kinds of like, I mean like, I don't know, like I don't want to like shit on everything, but like these kind of like blatant money grabs. Like, that's just kind of my take.
I mean, the early internet was very open source, and Amazon one-click comes around. That's a landmark patent, changed everything. So, I mean, I think there's these shock moments when you look at IP strategy that embody a single patent that captures massive value and then people fall. So I guess we'll see if that happens.
I mean, like AT&T Bell Labs from the 70s, a lot of their ability to continue their operations was just AT&T, like,
Which is very well celebrated. It's like one of the...
and all of the crazy technologies we use today are based off of almost everything that was coming out of Bell Labs. But like they were like incredibly intense about enforcing their patents on telecommunication. And like, I mean, I'm not saying that's what we have to do in order to survive, but like maybe, yeah, I don't know.
Do you think that looks different in a decentralized world, and how does that play out?
I think the fact that everything's decentralized means that everyone has to build everything themselves, and that's really slowed everyone down. And like
4 different environments, or
well, like, yeah, sort of. I mean, like, you know, if things are open source, you can build on top of everyone else's open source infrastructure. But if there was a concentration of effort onto a single solution, that could potentially be a lot faster than, or a lot more performant, or more ergonomic, more user-friendly, or something than like a decentralized collection of 50,000 different solutions.
yeah.
I do think it's interesting what you mentioned about how research and development funding happens. I think it's kind of common at this point that the incumbent funds R&D development, which drives their disruptor, and then empowers their disruptor to disrupt the incumbent. So Google funds AI research, funds Waymo, like self-driving research, funds all of these things, right? And by pushing that frontier, funds autonomous drones. By pushing that frontier, which is a massive capex for that company, it's probably the case that Google's going to get disrupted by an LLM-driven company.
AT&T funds computers, etc. Now we have the internet. No one uses cell phones anymore.
Now you don't care. It's just dumb pipe. That's not great for AT&T.
Yeah.
Crypto in some ways is, I guess, like through token launches, speculatively R&D funding, maybe its own disruptor. I don't know.
Yeah, maybe.
I should hope that my child one day kills me. Okay. I think we're nearly at time, so if anyone has any questions, now's the time. Otherwise, thank you all so much for coming to ZK Dive 3. Maybe one last clap for the speakers here, and then we'll call it a night.